All right, in this video, we're gonna be talking about factoring special cases. So let's just get right into it. So we're gonna factor this one like we would normally, and then we'll review it and see what's different about it. So A equals 1, B equals 6, and C equals 9. If you haven't already watched the first factoring video, I'd suggest you watch that now. If you're not familiar with the diamond method and the box method. So from here, let's use our diamond. A times C, that would be 9x squared. And then on the bottom, we have B, which is 6x. So what are the factors of 9? We have 1 and 9, 3 and 3, and that's it. So do any of these add up? 1 plus 9, does that equal 6? No. 3 plus 3, does that equal 6? Yep. So that's 3x and 3x. I'm going to circle those because those are the only things I'm taking from this diamond. Now, let's make our area model, or our box. Remember, ax squared always goes in the bottom left, and c always goes in the top right. And then we fill in whatever we got from our diamond in the other two boxes. So now we ask ourselves, what does this column have in common? What's a common factor between these two? X squared and 3x. In this case, it's just x. In fact, at this point, I encourage you to pause the video and try to solve the rest of this problem on your own if you can. Otherwise, I'm just going to solve it right now. So then here, we have x squared and 3x. That's also just x that it has in common. Then x times what right here equals 3x. It's positive 3. And then x times what right here equals 3x. It's also positive 3. So what we end up with is x plus 3 times x plus 3. Now here's the thing. You guys have all seen this before. Let's take a break from this for a second. You guys have all seen this before. X times x. And we know that that equals, we know that that equals x squared. Well, why does that equal x squared? It's two of the same exact thing multiplied by each other. Now take a look down here. We have two of the exact same thing multiplied by each other. So we can rewrite this as x plus 3 squared. This is what we call a perfect square trinomial. This is one of our special cases. Honestly, I usually don't encourage students to look for the pattern that this has, because I don't think that's very apparent when you look at it, especially when there's a coefficient in front of the x. But know that when you end with two of the same exact, what do they call these, terms, two of the same exact binomials, you can combine them to be squared. So that's what a perfect square trinomial looks like. And we'll use that a lot in chapter 5, actually, with completing the square is what we call it. Let me show you guys another case. So we have x squared minus 9. So this is what we call a difference of squares. These are unique because they have no b term. The b term is the one with the x attached to it, like the 6x up here. So this one has no b term. And also it has to be subtracting. If it's adding, it doesn't work. In fact, that would be unfactorable. But because it's subtracting, this is a difference of squares. So you could do it this way, like we've been doing it, and you'll get the right answer. But there's a shortcut for this one. And the shortcut, I'll show you, is to take the square root of both of these and then plus and minus them. So what I mean by that is, first step is we need to take the square root of x squared. So square root of x squared is just x. So those two would go right there. And then we take the square root of 9. The square root of 9 is just 3. So those go there. This is a very, very simple shortcut that will save you so much time if you know what a difference of squares looks like. Now, of course, there are more complicated ways that we might throw this at you. For example, if we have something like 25x squared minus 1, this is a little bit more complicated of an example, but the process is still the same. So we're still going to have a plus and a minus, but what's the square root of 25x squared? Well, the square root of 25 is 5, and the square root of x squared is x. So that means that 5x is going to go in these spots. And then, what is the square root of 1? The square root of 1 is just 1. So those go there. Once again, this is a very, very simple shortcut that will save you loads of time rather than doing the whole diamond and box every single time. But there has to be no b term, and it has to be minus. It has to be minus. So finally, I want to show you guys probably the most complicated thing that we can throw at you, which is the idea of GCF then factoring. So I remember in the first video, I said always check for a GCF first. And none of those really applied to it. So let me show you what I mean right now. So if we have something like 5x squared plus 10x, actually here, let me make sure that I'm doing this right. Yeah, okay, 5x squared plus 10x plus 5. I want to make sure I give you guys a factorable one. So here's our expression. Now the very first thing that we should do for all of these problems, all of them, even these ones, is check if there's a GCF first. Does any number that go into x squared, 6x, and 9? No. So then we begin. Does any number go into x squared that also goes into 9? No. So we begin. But on this one, is there anything that goes into 5x squared that goes into 10x that also goes into 5? And the answer is yes. 5 goes into all of these. So I divide each of them by 5. Now I have 5. Remember, this is the opposite of the distributive property. So 5 times x squared plus 2x plus 1. So now what I'm going to do is I'm going to do now I proceed with the diamond and box method like I've been doing, but I only focus on this part right here. And let me use blue actually. Now, we're going to ignore the 5 for now, but it's very, very important you don't forget about it. It's going to come in handy later. And in fact, you would get the wrong answer if you forget about the 5. But for now, we're going to ignore it. So we're going to, let's see. We're going to assign A, B, and C. So A equals 1, B equals 2, and C equals 1. Right? So let's make our diamond. A times C would just be x squared, right? 1x squared. And then B is 2x. So what are the factors of 1? Well, that's easy enough. That's just 1 and 1. Conveniently, 1 plus 1 equals 2. So I'm going to grab these from my diamond, put them into my area model. Now remember, I'm taking everything from this underlined expression, not up here, because that would be working backwards. I'm taking them all from this underlined expression. So that would be x squared and positive 1, and then we have 1x and 1x that go here and here. So what do x squared and 1x have in common? Answer is just x. What do x squared and 1x have in common? Just x. X times what equals 1x? That would be positive 1. X times what right here equals 1x? That would be positive 1. So we've written it before as x plus 1 times x plus 1, and then we stop there, right? And in fact, I accidentally made a perfect square trinomial, just on accident. But regardless, this is how we usually end it. But here's the thing. Remember I said we were going to remember that 5? We bring that down. We put it right here. So then we, everyone say hi to Mrs. Ibrahim.
Hi.
So then this is also a perfect square trinomial, so we can combine these two as well. So we get 5 times x plus 1 squared. This would be the most correct answer that you could answer on your paper. That's about all there is to it. Those are the 3 special cases, so best of luck. Practice makes perfect.